Electromagnets are used to make electric bells, magnetic relays, telephone, and many others. The electric bell consists of two solenoids wound in the opposite directions, on two soft iron cores joined by a soft iron yoke. When the bell push is pressed, a current flows in the coils of the electromagnet. The cores and solenoid become electromagnet when current flows through it. The soft iron armature attracted towards the magnetic iron cores, and become disconnected from the contacts. The hammer hits the gong very quickly to produce sound. When the iron armature is disconnected from its circuit opened and no current flows, the electromagnet cores lose its magnetism. The steel plate spring returns the iron armature to its original position. The circuit is closed again. The cycle is repeated so long as the bell push is pressed, and continuous ringing occurs. The electromagnet of electric bell repeatedly switches itself off and on very rapidly. The magnetic relay is a solenoid switch worked by an electromagnet. It is used in a circuit which controls the operation of another circuit, especially if the current is large in the second circuit. When switch in the input circuit is closed, current flows in solenoid. The iron core is magnetized to become electromagnet. Electromagnet core attracts the iron armature towards it. The movement of the iron armature closes the contacts in the second circuit, thereby turning on the second circuit. When the switch is turned off, the soft iron core loses its magnetism. This enables the spring to bring the iron armature back to its original position, causing the contacts to open and subsequently turning off the second circuit. A telephone contains a microphone at the speaking end, and a receiver at the listening end. When someone speaks into the mouthpiece of the telephone, sound waves cause the diaphragm to move backwards and forward. When the diaphragm moves inwards, the carbon granules are squeezed closer together, and their electrical resistance decreases. When the diaphragm moves outwards, the carbon granules spread out and their electrical resistance increases. The variations in the resistance of the carbon granules cause the current flowing through the microphone to vary in a similar way to the sound wave variations. The varying current from the microphone flows through the coils of an electromagnet in the earpiece. This pulls the iron diaphragm towards the electromagnet by a distance which depends on the current. As a result, the diaphragm moves in and out, and produces sound waves that are replicas of those that entered the microphone. Thank you for taking time to watch this.